Hello everyone, welcome back. Today I'm going to be talking about solving exponential equations with different bases. So, as we know, if we solve an exponential equation with this where the bases are the same, we just have to figure out what value of x we would have to get it to so that the exponents were the same. However, in this situation, we have different bases. So we need to alter one or both of the bases in all of these cases in order to solve for x. So here they're asking 5 to the power x is equal to 625. Well, is there a way that we could change one or both of these bases in order to get the bases the same? Can we easily make both of them either 625 or both of them 5? Well, recall that 625 is the same as 5 to the power 4. So in our next line, we would have 5 to the power x is equal to 5 to the power of 4. Because again, 625 is the same as 5 to the power 4. And now we have the same base, so we can ignore the bases at this point and say that x is equal to 4. Okay, let's use a similar method for part B. Here we have 9 and 27. Is there a way to make both the bases 9 or both of them 27 or both of them something else? Well, it's not going to be that easy to make them both 9 or both 27, but we could make both of them 3, right? We know that 3 squared is 9, right? 3 squared is equal to 9, and 3 cubed is equal to 27. So I'm going to replace 9 with 3 squared. So 3 squared to the power of x plus 5. And then 27 to the power x, well, that's the same as 3 cubed to the power of x. And recall from our exponent laws that whenever we have a power to a power, we multiply the powers. Also recall, especially for the left side here, the distributive property that we must multiply the 2 that's in the square by x and by 5. So over here, we're going to get 3 to the power of 2x plus 10 is equal to 3 to the power of 3x. Now we have the bases the same, and we just need to equate these, and we will get that 3x is equal to 2x plus 10. Then if we subtract 2x from both sides, we get that x is equal to 10. And this is something that we can check with our calculator, right? We can plug in 10 for x and say, and just make sure that that is correct. And it is, right? So what we're going to do is we're going to check that 9 to the power of 15 is indeed equal to 27 to the power of 10. Just by typing both in your calculator, you can verify that that's the case. And I do recommend doing that to check your work, especially for bigger questions like this, where it's easy to make a small mistake, like forgetting to distribute the 2 into both the x and the 5, or adding instead of multiplying somewhere or something like that. It happens. Okay, let's try part C. 4 to the power x is equal to 64 cubed. Okay, well, I don't know that we can really change the base of the 4 that easily to 64 or to something like that, but we know that 4 cubed is 64, right? So therefore, 4 to the power x is equal to 4 cubed, right? And 4 cubed, well, we know that when we have a power to a power, we multiply the powers. So 4 to the x is equal to 4 to the power 9, which means x is just equal to 9. And again, we can verify that, right? We can type in our calculator 4 to the power 9 and also 64 to the power of 3 in our calculator and see that those are indeed the same thing. All right, last but not least, we have 4 and 8 as our bases here. Now, it's not really going to be easy to go from, to make them both 4 or make them both 8. However, we can make them both 2, right? Recall that 2 squared is 4, and also that 2 cubed is 8. So therefore, we can switch the 4 to 2 squared. So 2 squared to the power 3x is equal to 2 cubed to the power of x plus 1. So now I'm going to multiply, right? Because again, power to a power, we multiply. So 2 to the power 6x is equal to 2 to the power 3x plus 3. So then I'm just going to equate these to get 6x is equal to 3x plus 3. If we subtract 3x from both sides, we get 3x is equal to 3, which means that x is equal to 1. And again, we can verify that by plugging 1 back in and saying, well, 4 to the power of 3, 64, and then 8 squared, also 64. And so it makes sense that x is 1 would be our solution here. So for these problems, it's very similar to when we had the same bases, but we did have the extra step of figuring out how to alter the bases in order to make them both the same before we could answer. If you have any questions, please leave them below.